I'm Jim Frazer, Vice President of Smart Cities and Infrastructure here at ARC Advisory Group. Today we're broadcasting from the ARC 2020 Forum here in Orlando, Florida, and I'm very happy to be joined by Arlan Nipper of Cirrus Link Solutions for a brief podcast on the subject of MQTT. So Arlan, let me just start with a very general introductory question. What exactly is MQTT?
Well, MQTT is a message-oriented middleware, or MOM technology. And if you look at that in the world of IT, they might call that an enterprise service bus. We used to call it service-oriented architecture. But what's unique about MQTT, it was actually invented on a project that we were on with Phillips 66 Pipeline for real-time mission-critical pipeline control systems. And that was in 1998. Now, what happened is that we made sure it was open when it was introduced. And in the last 6 or 7 years, all of the cloud providers, AWS IoT Core, Microsoft Azure, Google Cloud Platform, IBM Watson IoT, all use MQTT as their primary messaging pub-sub system to get IoT information into those cloud service platforms.
Oh, that's absolutely fascinating. I know there's a plethora of protocols out there. So why is MQTT important?
The important thing about MQTT is protocols are evil. All of the protocols, and I've been doing this for 42 years, and they are evil.
Okay.
So Modbus came out in 1978. It just turned 42 years old today. Modbus is still the most used industrial protocol in the world. So if we look at the hundreds of industrial protocols, they're not getting any closer to our dream of industrial Internet of Things or smart city infrastructures.
So what applications does MQTT cover?
Well, that's interesting. We invented it for real-time pipeline control system. It kind of stayed hidden under the covers with IBM. And then all of a sudden, about 8 years ago, there was a blog from Facebook, and the Facebook Messenger team were having trouble getting Facebook Messenger to work efficiently, be power conservative on their phone. And they looked around and they found MQTT. So there was a blog post on how Facebook, in 3 months, were able to develop Facebook Messenger using all of the highlights of MQTT. Simple, bandwidth efficient, stateful. So from that, it just kind of blossomed to where now when you get your Raspberry Pi, MQTT is on it. When you talk to your Alexa device and you're sending commands to your Raspberry Pi, that's using MQTT. So now we have this technology that probably all the college kids that are going to school have a Raspberry Pi. So I guess the understanding of MQTT, I would state, is probably more than any industrial protocol that's out there.
What an incredibly serendipitous development. I'm sure you forecasted that at the beginning of the project.
Oh yeah, right. We had no idea. Again, the interesting thing to me, and I'm very happy to see MQTT adopted like it is, but Andy and I were just trying to solve a problem for Phillips 66. That's all we were trying to do. But it was a very straightforward, common sense, simple. That's very, keep it simple, stupid. And I think that's why Modbus is still around. Is hey, it may not be sophisticated, but it's simple and it works.
So, and here's another question. So, is it documented somewhere? Has it evolved to the level of a standard?
So early on, it was just MQTT. The spec, Andy and I worked very hard to make sure that IBM, in 1998, that was a challenge for IBM not to patent it, but to make it open. So we did make it open. Well, then we started seeing AMQP get some things because AMQP had gone through standards. So 10 years ago, we took the MQTT specification to the OASIS International Standards Body. So now it has IEC certification, standards body, as well as the OASIS standards body. So it has 2 international standards bodies behind it, and it's officially MQTT version 3.1.1.
Superb, and it's So basically, if someone wants to implement it, they can buy the standard and they can become interoperable with MQTT systems.
They can download it for free.
Even better. Even better. Well, that's an incredible story and a great historical perspective on MQTT. Let's bring this conversation to today. What value does MQTT bring to some of the domains that we all work in, from myself in smart cities and public infrastructure to the oil and gas industry to discrete manufacturing?
Well, I think you're going to see, and we already know that MQTT is heavily in use in smart city, but the real value of it is, and we're working on another specification to help define these messages that we're publishing, and it all gets down to what we're calling a single source of truth. In other words, use MQTT to decouple your devices, connect devices to infrastructure, just like the Internet of People, but let's do it with devices. We still are secure. We still use TLS security, but let's connect devices to infrastructure. Then I don't want to know about that device. I don't want to know about its protocol. I want it to publish interesting information that it has. It publishes that information into infrastructure. Then applications can subscribe to that information as they want to. So what you've done, and I go back to my protocols are evil, is that you've basically defined an object, if you will. You're publishing it, and anybody can subscribe to it. That single source of truth means let's say it's a pressure or a temperature on the road. Not only does it come in and say the temperature came from this location, it gives me the engineering units, it gives me the engineering ranges, and it gives me the timestamp in millisecond when that value was published.
Great. So this is a messaging technology. I'm very familiar with the 7-layer OSI interoperability model. So I'm guessing MQTT fits one or more of those middle layers.
Yes.
So with that in mind, you, in your previous response, talked a little bit about defining the actual syntax of the messages.
Correct.
So, we've been involved a bit with ARC with Project Haystack coming out of the HVAC world. Can you talk about any initiatives that you may know of in that area for defining those messages?
Yes, we just actually yesterday there was a press release. The Eclipse Software Foundation, which is the largest open source software foundation in the world, announced the formation of the Sparkplug Working Group. The founding members are Chevron, HiveMQ, Canary Labs, Inductive Automation, Cirrus Link, and O-Ring. And those, what we've done is said, look, Sparkplug-B defines a well-known topic namespace and a well-known payload, if you will, process variables, temperatures, pressures, RPMs, things like that. And that took off. We had no idea how fast that was going to take off. So we contributed that to Eclipse, and now they are going to take that forward. So as people come in and say, hey, Arlan, we want to add this capability to MQTT, but we want it well defined within the Sparkplug specification. And I think we found that the Eclipse Software Foundation, because remember, software is eating the world. We're taking this into a company that has a GitHub. They have a Jenkins build. They know how to do software. So I think it's disruptive in the industry to go to an open source software company with something you want to use industrial. But I think if we're going to scale, again, HTTP and HTML technologies cause the explosion of the Internet of People. We've got to have that same thing in smart city and in the industrial Internet of Things. So if I have a transport that's already dominant, MQTT, and I have a payload representation, Sparkplug, then I've got that same capability to scale at the rate that the Internet of People scaled.
Absolutely agreed. For things to scale and to go viral, the impediments need to be removed. And some of that is the syntax in that highest level application layer. No doubt about it. Can you tell us a little bit about Sparkplug?
Well, Sparkplug basically the really good thing about MQTT is you can publish anything you want on any topic. So Facebook uses it, and Genie garage doors open and close with it. But the bad thing about MQTT is you can publish anything you want on any topic. So what the Sparkplug Working Group are working to define is a well-known topic namespace and a well-known payload representation, so that when we publish something, anybody that's subscribed to it can know what it is and know where that tag came from. And I will mention here before we go too far, this is bidirectional. MQTT is not just publishing from the device in, but remember, we designed it for real-time SCADA system. So it is bidirectional and it's stateful. In other words, you know the state. So if I've got 1,000 booster stations on a pipeline, I know the state of all of my edge devices in real time.
No, that's fascinating, because I think one of the impediments there is just what we both stated, is that that language level, the application layer, interoperability that doesn't exist. And it's interesting to us here at ARC and beyond that the Project Haystack initiative is about syntax only at that application layer. And it comes out of the HVAC world. So it's really just a labeling mechanism. They don't write the labels, but it's a labeling mechanism. Similarly, in the transportation domain that I come out of, all of those 19 different edge devices that can sit on a road also now have an unambiguous logical object with engineering units and a legal range, and it's there, a publish to subscribe model. There it happens to be SNMP, which is interesting. But the whole world is going towards an interoperable plug-and-play system. We see the scalability that happens. We need to remove those impediments, and often, the examples I use is no one thinks about buying a USB mouse. You just buy it, it plugs in, and it works, right?
It's exactly, and
it just works,
right?
And yet, perhaps for the newer listeners, often when I talk about the 7-layer OSI model, I remind people that at that application layer, you can't just use alphanumeric characters, because you can combine them into French or English or Spanish, and they're not going to work together.
Exactly. And that single source of truth, being able to put those labels on there. And I find it was very interesting in that the modeling of SNMP and the capabilities we've got with the extensibility of the Sparkplug specification, we could probably adopt that very quickly with MQTT. And the nice thing you would have there is, again, you were talking about, roadside signals and things like that. The thing about SNMP is it's not stateful, and MQTT is stateful. And that's very important. A lot of the customers I talk to is that smart cities, smart oil and gas, is that at the operational level, I've got to show an operations manager a better, faster, more secure, more scalable, more available operational system, first and foremost. He's not going to jump on board for digital transformation if he ends up with a worse operational system. Agreed.
Well, this has been a fascinating discussion. Let me ask you one more question. We're here at the ARC annual forum. You're an attendee here. You've known Andy for quite a while. What value does attending the ARC forum bring to you and your ecosystem?
Well, I had done. It's ironic that actually I was a co-presenter with Steve Koenig from Phillips 66 19 years ago at the ARC forum. And guess what? It was about MQTT. Yeah, that's a good historical tidbit. No, it's when I co-founded Cirrus Link, we partnered with Inductive Automation, and Inductive Automation are a big sponsor of ARC. So 4 years ago was the first time I had been here. But I find it very fascinating, the ecosystem that is here, and really the first ever announcement of the MQTT modules that we did in conjunction with Inductive Automation were at the press conference ARC 4 years ago. So we come back every year, and it just gets bigger and bigger. We have a big breakfast, and now it's almost standing room only. So I think it's a very good launch for the beginning of the year to say, hey, here is our technology roadmap for the next 12 months. And ARC is the perfect place to announce that and then to get the customer feedback.
Well, thank you for that. Do you have any last words?
No, I think that's it. I'm glad that you and I got to get educated on Smart City, and you got to hear about MQTT.
Yes, thank you very much, Arlan. You've been a great guest. Thank you again, everyone, for listening out there, and we'll see you again on another podcast very soon.